we are getting into what algebra is all about today, and that is how to solve an equation. Now, we're going to get into equations where you have to do like 3, 4, 5 things to end up getting a variable alone. But today, starting off simple, and we're just doing one-step equations. Okay, so what's the point of this? Well, the goal of solving an equation is to get the variable alone on one side of the equal sign. Okay, so you're not going to stop solving these problems until you have like x equals 5 or y equals 2. Okay, you have to have the variable alone on one side. In order to do that, you do the inverse operation of what is being done to the variable on both sides. Okay, so I want you to make a note. Inverse just means the opposite. So like adding and subtracting. Those are called inverse operations. Those are opposite operations. So if they're adding, you do the inverse, you subtract. It's very important to note that whatever you do on one side of an equal sign, you have to do on the other to keep it balanced. All right, I want you guys to also keep in mind that you can always check your answer when you're solving for a variable. So that's important. We're going to do that today just to kind of maybe get you in that habit. You can always see if you're right. So a few examples for you, 5 to be exact. I want to solve each one, which means I want to get the variable alone. So here's what I'm going to suggest. If I look at my equation, it has an equal sign, so it is an equation. Y plus 2 equals negative 10. I recommend that you draw a vertical line through the equal sign, because whatever you do on one side, you have to jump over and do the same thing on the other side to keep things balanced. So my goal is to get y all alone. If I can get rid of that plus 2, I'm good. So you do the opposite to get rid of something. So we're adding 2 to y. The opposite of that would be to subtract 2. 2 minus 2, you guys, is 0. So those cancel each other out. Like I said, whatever you do on the left side of the equal sign, you have to come over here and subtract 2 on the right as well to keep it balanced. Since the 2's canceled, I just have, let me use a different color, I just have y on the left side. Bring down your equals. On the right side, I'm just going to do the subtraction problem, negative 10 minus 2. Think of your number line. You go further left. That's negative 12. Okay, once I have the variable alone, I stop. I definitely want to check this though. So I'm going to use my blue again. To check it, you plug negative 12 in where y was. Okay, so the original equation looked like this. We just figured out that y equals negative 12. So instead of putting y, I'm going to plug in negative 12 where it was. And I just have to see, does this actually equal negative 10? And use your calculator to check if you need to. Yeah, negative 12 plus 2, that does equal negative 10. So if it works out to be the same thing on both sides, that means it worked. That means you got your answer right. Okay, let's do the second one. So I'm going to start by drawing my line through the equal sign. This time the variable, m this time, is on the right, but the goal is still the same. I want to get m alone. So I know that if they're just pressing two things together, like they are with the negative 6 and the m, that means that they're multiplying them. And I have to do the inverse, or the opposite, to solve. So if they're multiplying, I know I need to divide. And we've seen that you need to write division like a fraction. Just makes more sense to write it like that instead of using the little division sign. So they multiply by negative 6. I'm going to divide by negative 6. Whatever I do on the right, I have to come over here and do that on the left as well. Realize that negative 6 divided by negative 6 is just 1. Those cancel out. You don't have to write 1. So I bring down my equal sign. Since the 6's are gone, it's just m on the right. On the left, a negative divided by a negative is a positive. And 36 divided by 6 is 6. Okay, Emma's alone, so I'm done. I'm just going to check my answer. So I'm going to copy the original problem, and we figured out that M equals positive 6. So I'm going to plug in, instead of writing M, I'm going to write 6. And I know that negative 6 times positive 6 is negative 36. It's the same on both sides, so I know I got it right. For example 3, I'm going to draw my line. And my goal is to get B alone, so I look at what's being done to B. We're subtracting a half. The opposite would be adding a half. And I need to do that on both sides. The 1/2, negative a half plus a half is 0, so those are gone, leaving just B on the left side of the equal sign when I bring that down. On the right, I have to do 3/4, plus 1/2. So I'm going to write that up here. If you didn't have a calculator, you'd have to resort to finding the common denominator. I'm going to go for 4. So that would make this 2 over 4. When I add the numerators, that'd be 5 over 4 as my answer. And I'm going to check it over here off to the right. So I'm going to plug in 5/4 where B was. And I'm going to see if I subtract a half from 5/4, is that 3/4? When you go to check, I need to do the subtraction problem, which again, you guys, requires a common denominator. So I'm going to change that. I'm going to multiply the second equation by 2, and it's 2/4. 5/4 minus 2/4, if you subtract the numerators, that's 3/4, which is the same on both sides, so it worked. Okay, 2 more examples. Example 4 here. You want to get A alone, that's the goal. I drew my line. Now, you got to think what this fraction means. If you see a fraction, that actually means division. They're dividing by 4. That's what they're trying to show you. The opposite of dividing by 4 would be multiplying by 4. Whatever I do on the left, I have to come over here and do that on the right. These 4's cancel. Okay, so I'm just left with A. Bring down my equals. 8 times 4, that's 32. A is now alone, so that means I can stop. And let's check our answers. Let's plug in 32 where A was. 32 divided by 4 is 8. Same on both sides, so I got it right. Okay, the last example. So I'm going to draw my line. Ooh, this one looks a little weird. I don't like the fraction. I don't know about you guys. You will see problems like this a lot this semester. Here's what I do, because like I said, I don't like fractions. I take the x and I put it on top with the 2. And you know what? I'm going to do the exact same thing with the negative. So those are arrows that I just drew. I'm going to bring the negative up top with the 2 and the x. Okay, so I just took the negative, put it up top, and I put the x up top. So I just made it like negative 2x, all of that over 5. That's the exact same thing as the original problem. And maybe that's a little bit easier without a calculator. So I need to get rid of negative 2 and get rid of 5 to be done with the problem and to have x by itself. Now, if you have something going on where there's 2 numbers, if everything's being divided by 5, like it is in this problem, you need to get rid of the 5 first by multiplying by 5 on both sides. That will cancel out those 5's, and you'll be left with just negative 2x equals 6 times 5 is 30. Now think, okay, you're multiplying x and negative 2, so the inverse would be to divide by negative 2. And I do that on both sides. Those negative 2's cancel, and I just have x equals 30 divided by negative 2 is negative 15. Okay, so that one was a little weird. I'm going to go ahead and check it over here. So it's negative 2/5, and we got negative 15 as our answer. That should equal 6. We're going to be using our calculators a lot this semester, so I'm going to show you how to plug this in. So I'm going to do negative, that's hard to see. That's better. Okay, so I'm going to do negative 2/5 times negative 15. I'm not even going to put the negatives in there because I know a negative times a negative is a positive. Here's how you type in 2/5. You do 2. That ABC right there is the fraction button. So you do 2 ABC 5 times 15. Okay, so that equals 6. Whoop. So I know I did it right.